we need to show here that the distance from A to C is exactly the same as the distance from A to B. And remember to find, if you've got 2 points and you want to find the distance between them, so if one of them's AB and the other one is CD, then the distance between the two is the square root of A minus C squared plus B minus D squared. Okay, or the other way around. Okay, so let's find AC first of all. So the length of AC is going to be the square root of, let's just note which is which, A, B, and C. So from A to C, I'm going to do 3 minus 1 squared plus 8 minus minus 1 squared, which is the same as, well, that's 2 squared plus 9 squared, which is the square root of 4 plus 81, or root 85. If we now find the length of AB, so AB is going to be the square root of, so that's these two, so 8 minus 1 squared plus, so 8 minus 1 squared plus 5 minus minus 1 squared, 5 minus minus 1 squared, so that is 7 squared plus 6 squared, which is the square root of 49 plus 36. And if we add 49 and 36, we again get 85. So AC is root 85, AB is root 85, therefore AC is equal to AB. Okay, part 2 says, find the coordinates, or write the coordinates of M, which is the midpoint of BC. Now, to find the midpoint of 2 points, you add the x coordinates, divide by 2, add the y coordinates, divide by 2, so you get b plus d, 2d divided by 2. So if we're going to find the midpoint of BC, so we're going to do 5 plus 8 divided by 2, and then we're going to do 8 plus 3 divided by 2, and that comes out as 13 over 2 and 11 over 2. You can just leave it like that, that's fine. Okay, part 3, show that the lines BC and AM are perpendicular. Right, to find the gradient of these 2 points, we will do the difference between the y coordinates, so b minus d, divided by, if we do it that order, b minus d, we have to do a minus c. So the gradient of the line joining at those 2 general points is that. Okay, so if we want the gradient, so to show that BC and AM are perpendicular, I'm going to find the gradient of BC and the gradient of AM. So the gradient of BC is going to be the difference in the y's. Well, that's 8 minus 3. So this, I'm going to write the gradient of BC. So it's going to be 8 minus 3 divided by, so 8, that 8 minus that 3, divided by 5, take away 8. So 5 take away 8, well 8 minus 3 is 5, 5 take away 8 is minus 3, so the gradient of BC is minus 5 thirds. Okay, I'm now going to find the gradient of AM. So AM, we've worked out that M is this point here, which is 13 over 2, 11 over 2, so this is M. I'm going to find the gradient of AM, I'm going to write A here, so that's minus 1, 1, so this is A. So I'm going to do the difference between the y's, well that's 11 over 2 minus 1, divided by the difference between the x's, so that's 13 over 2 minus minus 1. Well, that's 5.5 take away 1, so that's 4.5. This is 6.5 add 1, which is 7.5. Now an easy way to simplify that is to actually double the top and the bottom. So 4.5 times 2 is 9, 7.5 times 2 is 15, and 9 over 15 is the same as 3/5. Now to show that the lines are perpendicular, we multiply the gradients together. So I'm going to multiply the gradient of BC by the gradient of AM, which gives me minus 5 thirds times 3/5, and I can see that if I multiply those two together, I'm going to get, well, everything cancels anyway, doesn't it? 1, 1, and 1, 1. The product of the gradients is minus 1, and we know that if the product of the gradients of 2 lines is minus 1, then the 2 lines are perpendicular. Right, part 4 says, what is the equation of the line AM? Well, we know the gradient of AM, we've just found that. The gradient of AM is this, it's 3/5. So the equation of AM is going to be y equals 3/5 x plus c. So that's just using y equals mx plus c. Now if we look at the line AM, we know it goes through A and it goes through M. I'm going to use A because it's a bit easier. So to find out what C is, I'm going to substitute that into this equation. So instead of y, I'm going to put 1. Instead of x, I'm going to put minus 1. Well, 3/5 times minus 1 is minus 3/5, and that's plus c. So to get c on its own, I'm going to add 3/5. So c is equal to 1 and, whoops, so it's going to be 1 and 3/5. So the equation of the line AM is equal to y equals 3/5 x plus 1 and 3/5. Now I can also write that as y equals 3/5 x plus 8/5. And to tidy it up a bit, I don't have to do this, you get full marks for getting that far. Multiplying by 5, we get 5y equals 3x plus 8. It's a neater way of writing it.